Good afternoon today to you, to our next webinar. Today, as we are going to talk about active setup of high available cluster, and this will be a bit advanced setup because we want to show how to achieve so-called zero single point of failure and how to achieve a maximum performance out of our HA active cluster. So what we are going to discuss today, there are a few points, and that's the first thing we want to show: optimal setup example. There will be probably more different options, but so far we were trying to get the optimal setting in our quality assurance with our quality assurance team, and we have found out the configuration which we are going to show to you today. So we will join, or we will combine bonding and multipath together, and we will try to show how it works together, how to connect to such cluster. We will also discuss options about volume replication connection, whether to use the 1 gigabit with round robin bonding or use single Ethernet. That's for performance, but if you want also zero single point of failure, that probably you can consider even bonding with 10 gigabit Ethernet. And also we will show how to set up with step by step how to set up this configuration chart, which I will show you in a few seconds. And we will make some simple tests. We will not make performance test today because of few reasons. We don't want to make this too long, and I didn't prepare the physical environment for our setup today. I will show everything today in the virtual environment, so it is easier for us and faster to make this. Okay, so may you please not click on the screen, because I have the recorded also the your clicks. Okay, so that's the setup today. For the first point of view, it looks like, whoa, that's complicated, but it is not. When we start to discuss what we have, then it will become actually easy. So because we are talking about a zero single point of failure, then we need to start with two switches in our cluster. Because let's say, what happened if I switch off, or I power off my switch? Yeah, I will lose the connection to my cluster. So I need some redundancy on the switch level as well. So I have two switches in my setup. Between us, in my configuration, which I will show step by step, I don't have these two switches because I'm using a virtual environment, but everything except the switching of the switch will be identical to this what I'm going to show to you today. So you will need to put the two switches, and you will need to put the kind of RSTP or trunking port, trunking connection between two switches, because you don't want to have a single cable between these switches. You want to have a redundant connection, and maybe for better performance you will need the two cables connecting to switches. So it is really important that you will configure RSTP or port trunking here. Okay, so that's the switches. Next point, of course, our node A and our node B for our cluster. So as you see, we have some more network ports than usually. Usually we were using 4 network ports. Today I have in my chart I have 1, 2, 3, 4, 5, 1, 3, 5, 6 ports, right? But actually in my setup today I will use one more, because on our chart here I'm showing ETH5 a single card, but in our setup I was configuring bonding. And here please be careful, for the bonding, for the volume replication I'm using a round robin bonding, so RR bonding. This is very important note, because only round robin bonding is in a position with such a point-to-point give us a better performance. Why we are in a position, I was always telling, in the point-to-point you will never get the better performance, except one case when we will have more than one stream, because in our active setup we will have at least 2 logical volumes, and we will have at least 2 volume replication streams. And this is why having 2 volume replication streams, this is why bonding round robin will help us also to scale performance. When you will make the bonding performance between workstation and the server, then of course when you will have 1.1 workstation you will not get better performance. You will always have multi point-to-point connection. But in this particular case, when we have the volume replication, the direct connection point-to-point without switch, using round robin method and having 2 streams will give us redundancy and will give us also performance scalability. Okay, so and next you see for the storage access I'm also using a bonding, and on top of the bonding we are using a dual virtual IP address. So here please note on first volume and second volume, which are replicated here. So first volume will be active on node A, and the second volume pair will be active on node B. So the first resource pool will be available via the first bond 0 and bond 1, and this on node A, and it will be available over IP address 192.168.21. This one means first resource pool, and 100, and will be available also over the second virtual IP, which will be defined first on node A, and that will be 192.168.31. 1 means first resource pool, 100. And here you see there is the target 0, right? So the second resource pool to which we will assign the target 1 and mirror 1, so the second one, so we will have the also 2 virtual IPs, and I put in the node that's node B 192.168.22. 2 means second resource pool, and as you see on the node B we have another one 192.168.32.100, and that will be exporting target 1. Okay, and from the storage client side we can also configure multipath. So the first path goes over second switch, and the second part of the first switch, right? Actually doesn't matter whether in which sequence we put it. And the next storage client, and even maybe next storage client. So we will have the multipath here. So we will be connecting to the target 0 via 2 paths, and that will be initiator IP 192.168.21, and of course when I have 2100 here, then I think something else, so 101 here, and over the second port 3101, okay, and that will be access to the target 0, and the access to the target 1 also via 2 ports, and that will be 192.168.22.101 and 32.101, and same procedure on the next storage client. Okay. Also, we will need some ping nodes in the network. The best idea is when the ping nodes are just on the storage clients, and that is the case that mostly we were configuring when we were using VMware extra VM kernel, which is giving us just an ideal ping node. In our case today, because I'm using virtual environment, I was also configuring VM kernels, but I could also configure next card here and give some IP address, which is exactly the ping node address, and have it working for me. So ping node is a quite easy thing to configure. We do not recommend to use a switch as a ping node. Why? Because a switch is well known as unstable ping node. This is quite funny, but our experience is giving us such a statement. Okay, switch is not stable answering for pings. It has from time to time some breaks, and this is not healthy for the ping node, because ping node need to be very stable. Okay. So that was, we will coming back to our chart a few times when we will do step-by-step configuration. So I was preparing 2 servers today. The 2 servers are already started, and because we don't want to waste time. And I was also already configuring volume groups and configuring iSCSI targets and creating the volumes. This is quite boring, and if somebody is not familiar with this, please go to our website, and just on the home page you will find the webinar with the active failover. That is very simple setup. And we start with from scratch with creating logical volumes. Also, you can go to webcast and videos. It is for sure another one which was prepared by me. Here is the German one, HA solution, and here is how to install. Okay, HA solution with VMware on DSS v7 as a virtual. So this is also starting from scratch. I'm starting creating the logical volumes and iSCSI targets and so on. Okay, but also most of us know how to create a volume group and how to create the volume. So I have created volume groups, and as you see, I have 2 volume groups. I don't really need to have 2 volume groups, but in our lab, when we were making a maximum performance setup, then we have installed 2 RAID arrays in our system. So the unit S001, it was a 1 RAID array, and unit S002 was a 2nd RAID array. Having 2 RAID arrays, we were also gaining some performance advantage, having 2 RAID arrays instead of having 1 RAID array. Then we were able to split some traffic between 2 RAID arrays, and it was faster. Of course, please make sure that the RAID array has enough hard disks. So we were testing this with 8 hard disks in the first RAID array and 8 hard disks in the second RAID array. In total, 16 hard disks. When you will have, let's say, 600 hard disks in total, then better make it with one single RAID array and make two volumes for active, because the RAID array, if you will make two RAID arrays with a RAID 5 with 3 disk only, then RAID 5 with 3 disk is quite slow. Okay, so this is here to show you that there is such an option. When you will have the maximum performance, then probably you will configure a few disks in the first RAID array and a few disks in the second RAID array, and we are emulating this here, and I'm having two volume groups. So in the first volume group you can have more logical volumes, of course, but to our demo I just make a 10 giga volume, and that's enough. And you see we have a block I/O. We do not support PHY I/O iSCSI volumes for active or active passive cluster in version 7. Okay, this is because of the reliability, so we can achieve the maximum reliability with the block I/O volumes. And you see the volumes are for marked for replication. So that's the volume 000, and then in the next volume group I have the volume 0100, and that's same block I/O and also 10 gig volume. Okay, so mirror settings, exactly the same settings I have on the second machine. I have here same two volume groups and the same volumes, so I will not waste time to show it. And also I have already configured iSCSI targets. So you know that when I want to configure a certain target name, let's say IQN 2012-09 and the colon mirror 0, then I just need to remove this checkbox, and then I can edit my target name and then create the target name which I want. Also, after creating the target, you can go to rename function and rename it to the name which is required, because as you know already, maybe some of you doesn't know, the target name on the both server for the first target must be identical. And there is one more small thing: when you create the target, the SCSI ID and LUN number must be identical. So I can prove it to you. So it starts with F, finish with AO, and then when I go to the second and the iSCSI target manager, you will see that here I was creating this with the identical SCSI ID number. So I was just copying and pasting this. It is good practice to use, you see, FA0, so that's the identical. It is good practice to use such a long random number, because then we have guarantee that this SCSI ID will be unique, and even some initiator will take only first part of this, will have no problem. In some very old presentations I was overwriting with this with 00001, 002 and so on. It works with some initiators perfect, but with some not. So the best practice is just leave such a long random number. Okay, so we have the volumes. The volumes are replicated. So when I go to volume replication, the volume replication function, that's the node B. Okay, on node B you see the first volume pair. I will have destination here, and the second volume pair I will have source here, right? And the node A is opposite, of course. Node A for the logical volume 00, for the first logical volume is source on node A, and this one on node A will be destination. Of course you may have more volumes. Then you will have, let's say, some 10 volumes source on the node A and another 10 volumes source on the node B. It don't need to be identical. You can have, let's say, 5 volumes as a source on node A and maybe 3 volumes source on node B, when you will see that on these volumes is also quite big traffic. then you can decide which volumes are active on node A on the left side and which are active on the right side. I'm using this terminology node A and node B, and also in order to make sure that I'm on the proper node, I can put the proper name. So in my name I was using something like DSS 4060, you see 4061. That's the ports which we are assigning to access this over internet. But we have the one important parameter which is called host name, and the host name is you see I already rename. So when you start, then you have a DSS and this random number, and instead of DSS I was putting node A here, and on the right side I was putting node B here. Okay, this host name is used in the failover resources pool setup, so I will see at once whether this is a resource pool which was assigned first to node A or node B, right? So please rename this, and please know that after rename and you apply, it will prompt to you for a reboot. You must reboot the server when you are changing the host name. You don't need to reboot when you are changing the server name, and the server name is this one which is showing also on the web GUI, on the web access in your browser on the top, right? Okay, so just to finding what we have done so far. So we have I will come back. Okay, our host name here I'm just putting node A. I'm not putting this random number, but this is very good practice also to have this random number, because when you will have more than one cluster set, then of course every host in network must be unique. This is why it is good practice not only to just put node A and that's it, but leaving this random number is giving you guarantee that you will have the unique host name in your network, right? Good. So we have the volumes. Volumes are set for the volume replication, and we have set the source destination properly on the both nodes. So the next step, and this is everything so far identical as we were doing with the V6. The only difference is that we have two volumes, and the one is source on the node A and another one is source on node B. It was not possible with active passive. On active passive, all the volumes must be source on the left side and the destination on the right side when you start the setup. Okay, now we have before we were having the mirror IP server. Now we have new function which is called host binding, and this new function will have a double functionality, because it will communicate here to replace the config files between node A and node B, and it will use this path for volume replication. So let us come back to our chart, and you see for the volume replication we want to use this path, right? So in my chart it is ETH5, but in our setup, as I mentioned to you, when I go to network interfaces, I was having a few more cards. So I have 0, which is the card which I'm accessing the GUI only. This is needed for my setup, and I have ETH1 and 2. This is bond 1. ETH3 and 4. This is bond 0. This is bond 1, and this is bond 2. And let me see the IP addresses. So bond 0 I was assigning 192.168.1.220, right? So when I go to bond 0 on the node B, then I will have 1.221, exactly as on our chart. You see 1.221, and here is 1.220, and that's my first storage access. The second storage access path is on bond 1, and you see that's 192.168.2.220, and here bond 1 is 2.221. Okay, that's exactly what is on our chart. Okay, 2.221. Let us remind our chart. Okay, we see on the bond 1 we have a 2.220, and we have a 2.221, right? So on these both bonds we will have a storage access. So in the subnet 1 and subnet 2. This is why our ping nodes are also in subnet 1 and subnet 2. Okay? And the last is the volume replication, and in my I could have one single card, and in such case we strongly recommend to have the when this is single card 10 gigabit Ethernet and point-to-point only. In special cases you can use the switch between, but the point-to-point is really strongly the most recommended setup. Okay, in my case I was also putting a bond here, and then exactly as in my chart I was putting 5.221 on the node B and 5.220 on the bond A. Okay, so now we have idea about the setup. So setup is exactly which we see here, that the IP is the same, but instead of single port I was having bonding here. And one more reminder to you, you see this bonding is balance RR, so that's round robin bonding. But these both bondings to storage access, it is ALB, so that's the, you see LAB, balance LAB, that's the adaptive load balance, and here as well. You can use round robin here as well, or some active backup, but active balance works stable and probably is the best fitting for this setup here. Okay, so let us go to host binding. So I'm go on the first node, but that will be exactly the same procedure on the node B. You can do it from node A or node B, doesn't matter. So when I'm on node A, so I'm giving my host binding IP, which will be also volume replication path here. So that will be 192.168.5, and because I'm on node A, so I need a remote IP that will be 221. Okay, if I will be on node B, I will enter 5220. Okay, so remote node administration password, I'm just having the standard password, so admin, and connect. So now both nodes will become a cluster. It will be still no failover setup, but they will be know about each other, and they will be able to exchange the configs each other. So every next setup I will do on one of the machines, that will be exchanged with the second machine, so we will not need to switch between machines. And that's the good stuff, because you will have less steps in order to finish the cluster configuration. Okay, so after I'm getting the binding done, I need to start or define my volume replication tasks and start the tasks, right? So let me see. The next option will be to define the task. It is still working quite a long time. I was actually expecting this to be done faster. Let me refresh the web, so I will just go one more time. Okay. The failover not, but the volume replication. Okay, so it was kind of a refreshing problem, but when I was entering the IP again, I see everything is done correctly. So on machine node A, I see here that my host, remote host, is a node B, and this random number, and that's the IP address. When I will switch to node B, then I have an opposite situation. My remote host here is a node A, and IP is 5220, right? So on the left side, so node A, I need to define the volume replication task. So let me put the name mirror 0 for this. And of course, I have only one option to select here. And because of the round robin with the 2 gigabit, so round robin 2 times 1 gig, I can enter even 100 megabyte per second because I have 2 volumes only. So per 100 gigabit you can just roughly about put 100 megabyte per second. Okay, so that's the tasks which is already there on the node A, and I can start the volume replication. So it is starting, and after starting I may prove that the volume replication really works and is consistent, because my volumes were created with the volume replication at once. They will be consistent at once. And anyway, I was doing some setup before and I didn't delete these volumes, then it must be consistent at once. So see, now I see the start time, and when I go to status tasks, then you see my volume, destination volume is consistent, right? Okay, so now we go on node B, and we need to create the mirror 1 task. Okay, so I'm creating mirror 1 task. I can also put 100 megabyte per second and create. That's the mirror 0 reverse task, which is automatically created, and now I have mirror 1 task created. And you see, on the node A, I have created by system mirror 1 reverse. Okay, so now next to mirror 0, system was creating, I was having mirror 0 starting this, and now system created 1 reverse. Okay, so now on node B, I need to start the volume replication for the second set of my volumes. In this case, it's only 1, right? But if I will have more, then I will have more tasks. Okay, and so starting takes few seconds. When I see that the date is there, it means the start time is there, means the task is started. Also, there is an event about it, information. I can make proof in the status tasks that the volume is really consistent. So the destination volume is consistent, right? Now the last step will be to set up volume, to set up failover. So in order to set failover up, we need to enter the ping nodes, auxiliary paths, and select the resource pool on A and resource pool on B. Resource pool, that is a set of the virtual IP addresses and the replication task. Okay, so now the start button is not active because we still didn't finish the configuration. In auxiliary path, you see I have already one entry, and that entry is bond 2, which is a volume replication, and on the volume replication we always set up the auxiliary path, the heartbeat path. So we just need to add both parts on which I have a storage access. So storage access is over bond 0 and over bond 1. So bond 0, add, and the bond 1, add, and that's it. So we see adding this on the node A, I will see the changes also showing on the node B. So as I mentioned, it is enough when you do the setup on the one node. Okay, you see the both auxiliary paths also exist here. Okay, since I entered them on node A. Let us enter the next one, so that will be bond 1, bond 1. Okay. So auxiliary paths are connections between both servers for the heartbeat to monitor whether both servers are present. This is why we need to have a very reliable connection. This is why we were recommending to have the one connection which is not using any switch. That will be volume replication, and here we have also heartbeat connection. This is why we have the quite stable, reliable connection between two servers. Okay, now next point is ping nodes. So my ping nodes, I need the in our chart we have the ping nodes 107 and 107. Okay, so I will try to enter these IP addresses. I was preparing this already. 192.168.107. Okay, and at 192.168.107. As I mentioned, I was preparing the ping nodes already. This is supposed to be the best on my storage client, but in my case, everything what I'm showing is not real, it is virtual. So you see I have a VMware server which is running my both machines, and here on the virtual switch, which has even no adapters, I have also inside the Windows machine which I'm using, and this machine will be connecting to this cluster. I have this 107 and 107 this VM kernel as a ping nodes. So that's my setup. For the teaching purposes this is good, but in your real setup, as I mentioned, you can configure this on your storage client. Okay, So that's our ping nodes. We need to have something reachable, otherwise we will be not able to start the cluster. Next function is how to react on the I/O failure. Of course, we want to trigger I/O. We will make failover by default if I/O appear on the node A, or if I/O error appear on node B. Everything what is active on node B will be moved activity to node A. Okay, so the last point are so-called resource pools. So in resource pools we need to enter virtual IP and SCSI, iSCSI resources. There is presentation on our how to resources. So when you go to how to resources and iSCSI and NFS failover, so you see 2012 September, there is a synchronous volume replication with multipath active iSCSI failover. When you download this presentation showing exactly the same setup which I'm using right now. So that's the presentation. When I open this, you see that that's the title, and it's just fresh made. And on the third slide, you will see exactly the chart which I'm using today for my webinar. And the next, you see all the steps are here, right? Step by step is explained what you need to do to enable this setup. So there is a few slides. When I go to the last slide, that will be slide number 51, and on the slide 51 you have already everything up and running, right? So everything is explained by step. That can be additional material for you to learn active and to make the setup in your place. Okay, so as I mentioned, we need the for the resource pool on the node A. On the node A, we need the resource pool which will be accessing target 0 over bonding 0 and over bonding 1. So that will be virtual IP 2100 and 3100. Okay, so let us do it. I add virtual IP here, so I click on add virtual IP. So that's 192.168.21.100, and this will be placed on the bond 0. Okay, so it is already actually selected. Net mask you need to enter manually, so 255, just class regular class C. Okay, so add. So that's the 21, and we need to add the second path with 3100, okay, which will be going over next bond, as we see on our chart. So the next bond is bond 1, and over bond 1 we will use the second IP, virtual IP, which will be 31. Okay, so I'm adding 192.168 and 3100. I will select here bond 1. Okay, bond 1, net mask, and add. Resource pool is a set of things which are which need to be managed by the failover cluster. So resource pool for this path will make sure that these virtual IP addresses will connect once to node A and after failover to node B, and it will switch. I need to add targets, so that's my task, mirror 0. Okay, I click on this arrow, then I can click on apply, right? So the resource pool consists of my mirror task, so the volume replication task, and my virtual IP or more virtual IP, if this is multipath, right? There is an option that I can have two virtual IP on two different paths. In my case, the path will be the bond, okay? But you, in some other cases, when you have a single switch configuration, then you will just use Ethernet ports, not bond. Maybe you will have no bond at all. The bond you will need to have the path redundancy when you will have the zero single point of failure configuration. So in resource pool of node A has these two paths, and this path, once when it's active on node A, is pointing to the network cards on node A, and after failover it is repointing, so need to be reswitched to node B. And same with the mirror, when it's active on node A, so the volume is active on node A, and then the same volume which is in volume replication is destination. So it's a source on node A and destination on node B. And after failover, it is switching, that is source on node B and destination on node A. Okay, so that's our resource pool. So the same resource pool we need to define on the node B for our next volume pair. Okay, so just now, when we have no active license, then we can define a resource pool only on one node, let's say on node A, to be active on the when I'm starting the cluster. Having a license for active, this gives us option to define the next volume resource pool. Okay, so now we have the virtual IP, so add virtual IP, and we need to add the virtual IP which is pointing to the second volume. Okay, so we have it here on node B. Because we start active on node B, that will be 2200 and pointing to target 1, and the 3200 pointing to target 1 on the bond 1. Okay, so let us do it. 192.168.2200, and for the 22 we select first bond. The first bond is the bond 0. Okay, we are done. So net mask, regular class C network, 256 addresses. Oh, it takes some time, but it is done already. Then let us repeat the same step for the second path, 192.168 and 32. The second bond, so bond 1. Okay, bond 2 is our replication, right? So for sure the second bond is 1, so 255. Great. So now we are done with the virtual IP addresses, which will work here in multipath. So this is why we have two. If there will be no multipath, there will be just a single IP address per resource pool. Okay, and then in resource pool on node B, we still need to add the volume replication task. So we go to iSCSI resources, add targets, and then we have only one single option here because I was defining only two volumes. Okay, apply. And that was the last step required for the configuration. Next, the last will be starting the cluster. So in my Windows, I have already some extra network adapters. So you see here, that's my access adapter, and that's my multipath adapter. Okay, so here I was defining 192.168.21.101. I will remind you my chart here is a 2101, and the second adapter will be 3101. Okay, so that's the second adapter, but on this adapter I have also alias, which is 21 and 22. Okay, why 21 and 22? Because 21 and 31, that's the path which is accessing the target 0, and 22, 32, it is a multipath which is accessing the next target 1. That's the reason. So on the first Ethernet I have 21, 22, and the second I have 31, 32. Good. So I was showing this to you. That's my 21, and that's alias. So I was just adding the alias. Okay. And the same procedure on this card. Okay. So 31 and 32. Okay. So now that was set up for my window to access this. So the cluster is not started yet. I'm ready to start. So look what happened on my ping. So ping to 2100, 3100, 2200 and 3200 is not answering at all. Okay, what happened when I start the cluster? So when the cluster is starting, then I supposed to see the activity here, answer on the pings, because the virtual IP addresses which I'm pinging, they will become available. So please remember, as long the cluster is stopped, the virtual IP address you don't need to ping, because they will not exist. So the virtual IP address start to life when the cluster is started. You can use the ping to see whether your cluster is already started or not, to monitor this, right? So you see now on my system is running okay, and of course that's the best to see on the ping nodes. Okay, the ping nodes are answering. Great. So now we would like to make some small tests, but before to make some small tests, I want to connect. I want to use my storage somehow. So the best will be to connect from VMware or Windows. I'm just prepared here to quick connecting to Windows. Also with multipath. I will remind you that we have the setup showing how to set up multipath under Windows. When you go to how to resources and to others, in others you will find how to configure DSS v6 MPIO with Windows 2008. In this presentation we do step by step, and also we show how to enable this under Windows. There are few tricks you need to know, so please download this presentation. I will only show you that the first step is you need to go to, when you have fresh installation, to Server Manager, and in Server Manager you must install Multipath. Sorry, that's the under Features. You see under Features I have Multipath installed. Today morning when I was trying this, Multipath was not installed, so I had to add feature, and adding features I had to use select the Multipath, but Multipath is already selected, so it's not on the list. After installing the Multipath feature, then you will have under Administrative Tools, you will have this Multipath icon. So when you go to Multipath icon, you need to start this, and in Discover Multipath, you will see this one not active. So you will need to add a support for iSCSI devices, and you can do it only when the connection to iSCSI exists. So as long you don't have any connection, you will be not able to enable this. So if it will be the case, just make any testing iSCSI connection, then click on this, add, and then you will need to reboot your Windows. Okay, after reboot, you can go to your iSCSI initiator. If you can't find it here, just write iSCSI, and then you have iSCSI initiator. Okay, the first step, go to Discovery, and just we need to enter the IP address of our target to discover the portal. So enter 192.168 and 21.100. Okay, so okay, something discovered. When you go to targets, refresh, then we see something on the list. We see IQN 2012-09 mirror 0. Okay, if both resources will be active on node A, then you will see also another one. But now with my starting situation, I have node A, and the resource pool on node A is active on the local node, and the resource pool which is defined on node B is active on remote node, means is active on node B. Okay, that's the reason I see only now when I'm entering this IP only one. Today morning when I was doing this just for testing, I was seeing at once because both resources were moved to node A. Okay, so that's inactive and we need to connect. So in order to connect, we click connect. Because we want to use a multipath, so we need to enable multipath, and in advanced we can select iSCSI initiator. We can select the initiator. Okay, that's 21, that's our initiator, and 2100, that's our target. Okay, 101, 100. Good, then we are ready, and now we see we are connected. Now we go to properties, and we need to add a next session. So next session, enable multipath, and we add the second path. So iSCSI initiator, 21 was the first part, so 31 is the second path. Okay, 3101 is our initiator, and 3100 is our target. Okay, so now we have a two path connected. Okay, so now I'm connected to resource pool which is active on node A, so target 0, and let us see whether I can already go to manage and storage. Okay, because a multipath is already installed, I see this disk as a single disk. When something wrong with your multipath, you will see the two disks, because every path will show the disk. So now I go to online, and now I need to edit the properties of this disk and go to multipath. Please note that as long as there is no multipath, this tab doesn't exist in Windows. Okay, so round robin, that's the proper. Okay, so now we are connected, and you see the disk is formatted already because I was formatting this today morning. So I can just let's say delete volume and do it one more time. So add simple volume. Okay, quick format, and I have the drive E available. Okay, so on the drive E I can go and let's say make some folder and so on, right? So the drive E is existing already, and now we need to connect to the second drive, second mirror. Let us do it. And so we need to find the iSCSI initiator. Now that's the mirror 0, right? So we need to go discover the second one. So discover portal, and now I will write 192.168 and 2131. So now let's say 22. That is already discovering my mirror 1. So I can go to connect, enable multipath, and select iSCSI initiator. Okay, now is a 2201 and 2200. So first is 22 and second will be 32. Okay, so that's the first path. Now I go to properties and I add another path for my multipath. So I'm selecting iSCSI initiator 32. That will be the second path. Okay. Good. So now I will see the second disk, and the second disk I putting online, and okay, new volume I can delete because it was used today morning. So new simple volume, formatted, and now I can go to computer, and I can also create some data here. Okay, so I have some data created. Let me make some simple test. So the very simple test will be, let's say, moving resources, right? Because now failover failback is just a move button. So you see I have a move button. Let me click on the move button, right? So I'm clicking on the move. Let me open all pings. I'm moving the resources from node A. So this is, you see, I have some small problem on node A only. And now, after moving, all resources are active on node B, right? So let me see and see whether everything is okay with my disk. So that's my disk E, and that's my disk F. Okay. Now you see when I go to status, a status showing me active on node B on remote mode, active on node B on remote node. So everything is active on node B. So I can change the situation. So now the resource pool which was starting active on node B, I can move to node A. Okay, and let's see what's going on. Now I will expect small problem on the node B. So the switching is done, and then let us see what's going on in our status. And now on the node B, I have active on the local, so active the resources which was on node B is active now on my local node, and this one is active on remote node. When I go here, okay, on the node B, I will see exactly the same information, a bit opposite, because the node B is first, node A is here. So node B have a resource pool which is active on actually on not on my node, but active on remote node, right? And the resource pool A, so the one which was defined on the pool on the node A, is active on my node B, on the local node. So now we have the opposite situation than when we were starting the cluster. Please do not stop the cluster with such situation, because you will manually need to move the activity source destination between two volumes, and you will have some clicks. Okay, so let us move back everything to the starting situation, and then also we can observe the pings. Okay, you see we are moved back. So now the resource which was defined on node B is active on remote node, means it is active on node B because I'm on node A. And this one I will move to the local node, so I will move the activity from remote node to my local node. Okay, I'm moving, so again I will show what's going on with ping. So that the 21 and 31, the one on the end is showing us that the resource pool on node A was moved, the activity was moved on my node A. Okay, so now we are back to the start situation, that the resource pool which was defined on node A is active locally, and the resource pool which is active on node B is active on remote node. So what happened when I reboot, let's say, remote node? Of course, everything will be moved to node A. So I go to maintenance, shutdown, and in shutdown menu we have the restart and shutdown as well. Okay, so let us restart this. Okay, it is prompting me that the system is in cluster, but okay, we want to reboot anyway. So now we can observe what's going on. So my second server will have a problem because it will go down. So now first action we have seen that the resources which were active on node B were moved to node 8 probably, and soon when the node B will be already shut down and rebooting, then we will lose the connection, web connection to this node. Okay, but of course we are having the ping. All the pings are there because I'm pinging to the resource pools. So on the left side, resource pool was on node A and stay on node A, and pinging to 3200 was pinging to the resource pool on which was active on node B, but in the meantime it was moved to node A, and the pinging of course worked. What doesn't work? The web GUI doesn't work. right? Or if I will ping to to physical Ethernets, then I will also lose pings. But because I'm pinging to storage, all the pings were just only having a short problem. Okay, so now waiting for the second, we can see what happened. So active on local and active on local. So everything is active on local. Here we have some unfortunate statistic. We lost 2 ping nodes from the second node. Actually, this statistic, now you see it is green because the second node is starting. And soon also this will be green, because when the second node is rebooting, it will make this available again. We have some bug on counting this when the when the cluster is in the gridded mode, but actually when you know about this, you can live with this. We will improve this in the future. So in a few seconds we will see that also auxiliary paths are available, and then after a few seconds web GUI will be available. The web GUI still is not available. I'm just trying to repeat, and it is connecting and having a problem. Okay, so that was the simulation, and by meantime I can go to my computer and see my volumes are of course having no problem at all. I could make some copy or some tests. You can do it also by yourself to make sure that your cluster is working stable, but in our training we have actually very little time, and I'm trying to spend the time to explain the things and show how it works. This is why I will also not make a lot of demonstration with the failures here. So now you see local mode, local node, and paths are already reachable, means that probably the second server is already up and running. Yes, that's the case. And when I go to the web GUI, then I will see okay, in the failover, that everything is active on the remote node. Okay, advantage here is that after such a reboot, the node is joining cluster automatically if there is no problem. So now when I want to come back to my start situation, I want the resources on node B to be moved back activity to node B. I can do it from node A, I can do it from node B. This is really doesn't matter. So when I go to resource manager, okay, see that's my node B, and my resource is active on the remote node. I can say move to local, okay, move, then again I want to show it. Now you see that the move was done. We see that the one ping was lost, okay, and in the status we see that the node B has a resource on local node active, and the node A has a resource which is active on node remote node, which means active on node A. Okay, when I switch to node A, then I see node A has a resource active on local node, and there is another resource which was defined on node B and is active on node B because on the remote node. That was about our active cluster setup, and I hope that the solution is now more clear for you. And of course you can use more ports for multipath. There is no need, like here you use what we have. You can use more ports, and there are also more options that you can use more ports for bonding And as I mentioned, here you can use a single 10 giga, or you can use bonding with 10 giga or bonding with 1 giga. There is a few configuration options. Please remember about port trunking or this RSTP configuration between your switches. Let me see if there are any questions. Okay. Let us see. Is it only for block I/O? We are using PHY-IO to use our big RAM to cache. A replication is possible. Yes, I know that the cache works well with the PHY-IO, but maybe for better performance you can use LSI Cachecade, or in the near future we are also trying to add some caching into our software, and so far we have decided to use block I/O only. Okay, next, how long until the beginning of the presentation? Okay, so I don't know when the question was. The presentation started at 4. For active configuration, is there a specific fiber channel controller recommended? Our active doesn't work with fiber channel, it works with iSCSI, so please use 1 gig or 10 gig iSCSI. Okay. Next. Hello, sorry but I don't see. Okay, sorry, but I don't see the real advantage of this kind of active setup, because of all the read-write operation for specific volume still happened at one side of the cluster. So example, for reading there is no speed improvement, or I'm overseeing something. Yes, you overseeing something, and as a proof, in the next days, once our white paper about performance analysis comparing active passive and active is ready, you will change your mind, believe me. In our performance setup, as I mentioned, we were trying to maximize, and we were using exactly this setup, bonding with multipath on top, and we were using 2 RAID arrays, and in plenty of performance pattern we were having 100% improvement, means double improvement. This paper, once ready, once they will finish, because so far is in draft, will be posted to our web for download. Next one. Has active been tested with VMware 5.1 yet? If so, what were the results? Yes, in my setup I'm also using 5.1. This is not really the test with 5.1. Okay, this is just running our virtual machines in 5.1. I was also doing some tests, and we have done very simple short test. We didn't see any problem so far, and in maybe next week or in 2 weeks we are starting the repeating the certification of the DSS, so that will be 5.1 with the DSS v7. So I'm sure it will go smoothly, because in case of iSCSI, between last certified v6 version and now we didn't change anything, so that should be no problem. And also from the short test I do not expect any problem with 5.1. Okay, I'm currently using OpenE v6 for the NFS daemon data stores VMware. Additionally, for higher tiers of storage we were using HP left-hand VSAs, virtual storage appliance. The setup you are showing is a lot of more complicated, as well as a lot more involved. The load is not distributed as in VSA models. So what is the selling point of the solution? How scale is it? So if you want high performance cluster, then for sure the external storage has the is the good way to go, because very powerful hosts for VMware, which are running plenty virtual machines and then additionally storage, then the cost for the very high performance host, VMware host, will be higher, and moving this to the external machine is a kind of good practice. And performance wise, you will be really convinced when you will read our paper, which I mentioned just a few minutes ago, which will be posted on our website soon, when we compare few performance benchmarking pattern, active passive against active active. So that's really convincing. Next question: will the NFS HA will be offered in V7? So far we have planned to make additional features to iSCSI failover. We are just finalizing persistent reservation, which will be supporting the Microsoft cluster, so Hyper-V cluster. This is planned. Also planned is to adding dynamically new volumes to running cluster and removing. So once this is done, then we are busy with the I/O PS, so with caching and some other stuff, like which are shown in our roadmap, and then we can try to come back to NFS. But in the next 5-6 months, for sure we'll not have this function in DSS V7. This is why the only way for NFS failover is still available DSS V6. Okay, that's all for today with questions. So we are just 1.5 hours, so it was long presentation. Even I was trying to show only as short as possible, but okay, I hope it was helping to understand the active-active solution. And I would like to say thank you very much for joining us. And as I mentioned, you can download the presentation from our FTP server. You can get the link just by email from the invitation email, and very soon it will be posted on our web. Thank you very much one more time for joining us, and have a nice day.